Okay, so basically tonight we're starting with chapter 6. Um, chapter 6 we'll probably cover in the next 2 or 3 sessions. I think it's chapter 6 is quite an important chapter um, for most of the work that we will be focusing on in the next few chapters. So chapter 6 will look at basically your normal distribution. Then chapter 7 will on that. Um, so and then when we go into the confidence intervals, hypothesis testing, it all is nearly part of normal distribution. So that's why I rather focus a bit more on study unit 6 or chapter 6, so that I think it's quite important for the rest of the study units. Okay, so I've shared a summary, I think this morning, this afternoon, around chapter 6. So, and you'll see as we go through some of the questions, this is quite and I don't want to use the word nice, but this is quite a study unit that they prefer to also look at some of the definitions within your assignment, but also within your exam. So they like to ask definition questions around study unit 6. I think that is just nearly an important note that we need to make. So they do like to ask things about when is something normally distributed. So the things that I think it's important is the things that they talk about, symmetrical, bell shape. You will look at the mean and the variance, so that will cover a lot in this section in any case. And then I think also what is important, we'll cover it as well, but I think what is really important is when we work through this study unit is to make sure that questions that they ask, and you will see they use a lot of the unit of measurement in this study unit, but when they do, we just need to make 100% sure that sometimes they give you one thing in kilograms and another thing in grams, or so we just need to make every time sure that the unit of measurement that we work with is exactly the same. And then the other thing that is quite important is we will nearly every time work out a Z, and then we will go to the Z table to see what the probability is. Um, so it is very important nearly that we don't need to remember the formula nearly, because again, it's open book. You have it. I'll share the formula pages that they normally would have given you a week or two before the exam. I'll share that with you with some notes on as well. So that is not nearly a thing to remember, but it is when you've calculated the Z, and when you go to the Z tables, that is what is nearly important. I'll and we'll go through a few examples of calculating the Z going to the table. So again, I want you guys to, when you go through this, to see which one is nearly the easiest for you to work with. So it might be that because you also get both Z tables, so you will get the negative and the positive. You have it in the book as well. So for me, it's more, I'll nearly show you, and it sounds now very confusing, but I'll show you nearly one or two methods that you guys can use. And again, it's what's the easiest for you. I'll also, when we're done with this study unit, I'll show you one or two ways that we can look at the data within Excel as well, so that you have another option to look at it. Also, possibly you will be able to use some of the other online tools. So I'll just check one or two other sources that you can also use. But basically, the most important thing for me about this study unit is that you're gonna need to solve a Z, and that Z you will need to go to the tables, so that you can get the probability. So that is nearly, for me, if I look at this study unit, that for me is the most important that you guys need to be able to do. When we get to study unit 7, 8, and 9, that is when we use the Z to work with confidence intervals and hypothesis testing and those kind of things, but that's a bit later down the ground. So let's first start with how to calculate the Z, how to get it on the table, how to get the probability from there on. Did they at all? And no, you don't need to, you can just put it in the chat, say when the next assignment will be available, or was there no comms on that yet? Then I'll just check in with the lecturer that they can give us some indication. I haven't seen any comms yet, so I was just wondering if any of you have seen when the next assignment will be released and when it's due. If not, I will just follow up with a lecturer tomorrow, just so that we have indication, so that we have timelines to work towards. Okay, so I'll just check in with him and see when it's due. Okay, so let's start with the study unit with one question. So they're saying here, and I think that you will, they don't need to say it, but basically they're asking us to, from the table, to look at the Z value and then to see which probability will fit. Before we even get there, I just want to show you some of the, so what you will see is, if you look at some of the probabilities, that one and that one will add up to 100, that one and that one will add up to 100. So depending on which table you will use, you will get different answers. So let's see what they give us here. Using the standardized normal table Z, calculate the probability that Z is bigger than minus 1,65. So all of my, when I look at these ones, I draw myself the normal distribution. Graph, they say at minus 1,65. So I know it needs to be on the left-hand side. The mean is in the middle, it's 0, so it needs to be on the left-hand side. So then what the next thing I will look at is, okay, so they tell us it needs to be bigger than, so bigger than, it needs to be bigger than 1,65. So this whole area is the probability that we are looking at. Okay, so if, let me just, so if I had the normal distribution and that was 0 in the middle, this side is 50% and this side is 50%. And I'll just quickly explain why. So we know that one of the rules of probability is everything underneath the probability curve will add to 1 or 100%. One of the other rules is that when you have a normal distribution, the normal distribution is symmetrical around the mean point. So symmetrical means what happens on the one side happens on the other side. So that mean nearly splits the normal distribution into two. So that, because it's 100% underneath the graph, it needs to be 50 on the one side and 50 on the other side. So if I look at this graph, and again, I want to show you how one can start eliminating answers. So I need to find this whole area. I know that this portion from what I've done here must be 50% or 0,5. So that I know already. So whatever portion I add here will give me more than 50 or will give me more than 0.5. So if I look at these answers, that won't be an answer because that is much smaller than what I'm looking for, because I'm looking for something that is bigger than 0.5. That is also not going to work because I'm looking for something bigger than 0.5. This is 0.05. So that is also not going to work. So if I then need to guess, at least I am down to 3 and not to 5. So let's then go to the table. So in your table, and let me just open my study guide as well, because I just want to quickly show it in the study guide, and then I'll go back to the notes that I have. So in the study guide, and let's go, it's around page, let's quickly see. Okay, study unit. So you guys can see how I did it last year. So around pages 120, 121, it's all there in this study guide. So how one looks at it, so they ask us to look at the bigger than 1,65. So, and look at what so we need to get this area because that is what they are asking us. So let's just look at those two tables. So the first table is nearly the opposite. So I'm actually looking for that bigger area. So it might be that we can use this table. There's a bigger area. The other one is, let's go to the negative table. I've got that small area and not the bigger area. So there's two ways that you can look at this or how to get to this answer. So what we can do is we can find this answer, and then one can say 1 minus this area, and we will get the bigger purple area. So that can be the one way. So then it's easy if we work with the negative 1,65, negative 1,65, 1,65 is 0,0495. So if we, I just want to write that down. So there it is. So if one then say 1 minus 0,0495, we'll get the answer, and that answer would be 0,9505. 0,9505, which is option 4. But also, if you look at this, you see that we want to look at the bigger component. So we can also go to your positive table at 1,65, 1,6, 1,65, 1,6, 1,65, and we can get the bigger portion of that as well. And why I can do that is because one of the rules is that I'm working with a normal distribution. So a normal distribution is symmetrical. So if I have -1, and this is a lot to take in, so don't worry if it sounds difficult at the moment. We'll sort out that you do understand by the end of the study unit. So again, if I look at that minus 1,65, that size, or that is exactly the same if I have, again, let's just make that 0. If that was positive 1,65. So those two areas are exactly the same. The reason why they are exactly the same is because we're working with a normal distribution. So the one is, and that is why it's called symmetrical, the one is basically the mirror image of the other one. So but we'll do a few of these nearly to get nearly that definition grounded, that we get to that final answer. So basically what we are doing consistently in this study unit, calculate the Z unless they give it to you, go to the table to find the probability, go to the negative table or the positive table and see which one suits nearly you the best in answering the question that you need. What's also important as we go through this, I think it's to nearly identify which one or which method is the easiest for you to look at. Because if what I've done, in the process, what I've done here, if that is easier for you to remember and to do consistently, do it like that. If you are able to look at it this way, and nearly use the different tables the whole time, and just remember that you can switch between the negative and the positive table when you do it that way. I will also show you later on how we do it in Excel. So there will be another option in there as well. So I think by the end of a study unit, you will be very comfortable in the different ways of getting to it. But let's first do a check-in. I think this is quite a lot of information that we've now nearly done in one question. So let's just get a quick check-in with everybody and just tell me what parts are you struggling with, so that we can just, and you can see there's lots of these questions, so it's not that we will not go through a lot of these examples. So let me just get a quick check-in with you guys. Yes, you can go. Okay, I can't hear anything at the moment, so let's just. Can any of you hear her? Okay, I don't know if it's only my connection that is bad, but I can't hear anything at the moment. Okay, so sorry, I can't hear anything at the moment. So yes, Over King. Let me just make sure that I can hear you. You can go. Over King, can you hear me?
I think he's still on mute. You need to unmute again.
Okay, cool. But I can hear you now, so that's a good sign. Okay, let's just continue, and if Elizabeth can, you can just if you unmute again, we can maybe, but otherwise let's continue. Unless, Obakeng, did you want to ask something as well? Okay, so let's continue. So you will see that sometimes they give it to you as a question to calculate, but they just tell you you need to calculate what is the probability of Z bigger or smaller or anything like that, or they can give it to you in the format that you need to calculate the Z, so that you don't know what the Z is. So then we calculate it, and again we'll use this formula. So we will be able to, and if they do this, they need to give you all the information needed. So they need to give you the X, they need to give you the mean, and they need to give you the standard deviation. So let's look at what they tell us. Long distance calls made by employees of a company are normally distributed, so we know that we can work with a Z. It's got a mean of, so we know the mean is 6.3. Standard deviation of 22 minutes. And we need to work out that the normal distributed table calculate the probability that a call lasts less than 7 minutes. So we need to calculate the probability that it's less than 7 minutes. Okay, so important. So the X was given as 7, but very important that we need to, when we write it out, that we remember to look at less than, so that sign is important here. So less than. Okay, so let me just check, is everything, we've got the 7, we've got the 6.3, standard deviation, sure, that looks so big. Okay, 22. Okay, so Z smaller than, so 7 minus 0.3 is 0.7. 0.7 divided by 22. So Z smaller than, sure, this will be a weird number, but 0.7 divided by 22. So we sit with 0.03. And it's actually, let's just put the whole 0.0318. Okay, so that will round off to 0.03. So we need to get the Z that is smaller than 0.03. Okay, so this is Z always in the middle is Z equal to 0. So 0,03 is just more than that. So let's just put 0,03. So we are looking for the area less than. So look at that, less than. So it's the area to the left of that because it's less. So again, nearly, if I look at this, we have it there as 0. So to this side needs to be 0,5. So if I add just a small sliver, I don't know what that is yet. We'll get it from a table now, but if I just add that small sliver to it, it will be a bit more than 0.5. So if I look at these options, it needs to be a bit more than 0.5. So I already will take out those two. This one is just a bit more, so that might be a nice one, or these two. But we are sitting with a probability that we will work out that is just more than 0.5. So we can go to the Z table. So again, if I go to this Z table, I would go to 0,03. So if we go to Z 0,03, we basically are looking at 0,5120. So, and the way that we look at the table, and let me rather write that down as well for you. So I can't, now, let me just, so the way that we look at the table, and it's nicely explained here as well. So let me write down the 0,03. So we go down the table for the first two values, so 0.0, and we go across the table for the second value. So down the table for the first two, so 0.0, across the table for the second one. So 0,03, the probability will be 0,5120, which is that one. So let's just look at the piece that I've copied in here. So 0,0 across 0,03, and there we have the 0,5120. So yes, a bit more than the 0.5, but not those bigger ones. So it is the 0,5120. Again, we'll go through a few more of these so that you can just get the hang of it. Okay, I'll just give me a, okay, I don't think there's anything else than a thumbs up, so rather give me that I can see a thumbs up or the surprise. Thumbs up is you understanding, the surprise is we need to do more, but there's also a question. Okay, cool. So question, I think is it Simon?
Aston, I'm a bit confused.
And
Can you just through the
yeah,
going down and going up again? I'm not sure what was
okay,
happening because I'm on my phone. I'm trying to move across as you are moving. But I'll
okay,
stay on the table so I see how you moved on the table.
okay, okay. So let me, and I think that is the let me, the best to show you on the table, let's go back to the 1.651, because the 0.03 is nearly only looking at the top part. So let's look at the 1.65. So if I'm on the table and I need to look for 1.65, so where Z is 1.65, and let me see if I can write here as well. Just want to see. Okay, so let me type it in here and then we can. So if we, okay, now I just want to see how can I get back to the other. Okay, so we will, the first two is where we will go down. So we will go down to 1.6. So we're at 1.6. So that is where we go down. So the first two numbers we go down to, and then the second one is the 0.05. So we will go across to the 0.5. Okay, and where those two cross, we will basically get the value that we need to work with. Okay, so if we looked at the 0.03, it was the 0.0, and the cross would have been the 0.03, and it would have given me that probability. The same, so let's randomly pick a probability of, or a Z value of 1.95. So if you needed to look for 1.95, you will go down to 1.9. You will go across to 0.5, and where those two meet, it would be the probability. Okay, so the first two, the something point something will give me where I need to go down, and the second number after the point will tell me how far I need to go to the right hand. The same if it was negative and I had, say, negative 1.55, I look at negative 1.5, negative 1.55, let's just see, and where the two meet would have been the number. So if I had negative 1.5, or let's use a different one, negative 1.07. So negative 1.0 will be that. Negative 1.07 will be where this 0.7 is. So it will be that probability. So it's basically the first two numbers, the 1.6 or the 1.7 or the minus 1.5. It's where you go down the table, and the second number after the comma is where you go across the table. Is that better, Simon? Okay, cool. Over King, you have a question.
Thank you. Can you hear me now?
Can hear you now.
Okay, thank you. I just want to know if is there any way whereby you can get the value of Z through calculation without using the table.
Let me quickly check. You can use Excel.
The
So
expression. spreadsheet
Oh,
that you did to us.
yes, yes. So we will. I'll show you in the next session how we can use the spreadsheet as well.
Okay.
Because I think the spreadsheet will also be easier, because then so the spreadsheet will be able to calculate the Z, and the spreadsheet will also be able to calculate the probability because it's built into one of the formulas. So I'll definitely on Saturday, during our session on Saturday, I'll definitely show you how to use the spreadsheet for that. Okay, cool. There's another question, Simon.
Yeah. Okay, now I understand. Sorry for that. I think one other thing that I'm lost with, you see, when you're coloring this distribution, you quickly cancel out number 1 and number 2, but I couldn't get around how you actually figured out that number 1, number 2 were obvious options that were not part of the solution, because I don't know how you got to the 0.5.
Okay, cool. So let me quickly and let's look at so let me put in just a new slide. So when we look at the normal distribution, in the middle of a normal distribution, the Z value is 0. So that means to this side of a Z value, there's 0.5 of the probabilities lying to the one side, and 0.5 of the probabilities lying to the other side. So if I have a value, let's say that's 1.65, and I need to calculate this area, then I know that this purple area will be smaller than 0.5, because if this whole area is 0.5, that small purple area must definitely be smaller than 0.5. So if I then get answers that says to me, one of the answers is maybe 0.65, then I can say, well, it can't be because my answer must be smaller than 0.5. I don't know what that answer is yet, but at least I can say I can eliminate that option because it needs to be smaller than 0.5. So that was nearly the same that I did here. Is by coloring in that area, I knew that that area needs to be bigger than 0.5, because here I already have a 0.5 and here I add an area to it. I don't know what that area was yet, but that total area in purple must be bigger than 0.5. So that's why I could eliminate those two smaller numbers. I hope that makes a bit more sense. As we go through some of the other questions, I'll keep on showing how to eliminate and how to look at that. Does that a bit clearer, Simon, or still?
No, I think I get it. So the purple area, you colored it because the Z is greater than negative 1.65, right?
Perfect.
So
yes.
all right, yeah.
Yes.
Number 1.
Cool. Okay, so but please, this is, for me, this is still one of the most difficult set or study units. So let's just make sure that the more questions that you want to ask, please do. Cool. So let's look at another one. So here we need to suppose the Z is normally distributed. They give us a mean, they give us the standard deviation. So that is nearly the same that we've got in the definition. So we know it's normally distributed. Here they tell us calculate the Z that it is smaller than minus 1,59. So if I just look at that again, there's 0. Let's say that is minus 1,59. It must be smaller than that area. So if I look at that, this tells me, okay, so that area will be 0.5. That total area, including that small part, will also be 0.5. So this area needs to be smaller than 0.5. Okay, so we don't know yet what it's going to be. We just know it's 0.5, less than 0.5. So if I look at the options, it can't be the first one, because the first one would have been the bigger area. The second thing, I'll get to the question now, Latifa. The second thing that we can also eliminate is a probability can only be between anything from 0 to 1. So we can't work with a negative probability. So that one I should have nearly scrapped from the start. So we can also not work with a negative probability. Okay, so there is a question. So before we go on, quickly ask a question.
Hi, Jean, can you hear me?
Yes, I can.
So I think I missed something. I'm not sure. How did you know that negative 1.59 is at that specific point on the graph?
Okay, cool. So I actually don't know. I just know that if I look at now, so let me take this away. So the only thing that I know is that when I draw the graph, I know that the mean is in the middle. I know that this side is positive. I know that this side is negative. So somewhere in this area is the minus 1,65, or sorry, the minus 1,59. So I just, for myself, make it easy and say, I'm looking for the smaller, so I'm looking for that area. What that area is, where it's plotted, I don't know yet. So just visually for myself, that is what I do to make it easier. Okay, so it's not that there's not something that I exactly know where that spot is. I just know it is somewhere there. Does that answer your question? Perfect. Okay, so then by knowing that area needs to be smaller than 0.5, we now eliminated the one option. We know it can't be negative, so we eliminated the second option. So we're sitting with 3 options. So this one, if you look at it, it is it is perfectly looking like this one that is colored in. So when we need to look at it, we can go to, what was it, 1,59. So minus 1,59. So let's go 1,5 minus 1,5. 1,59 is way to the other side. So there we have a number of 0,0559. Okay, so we went down to the first two, the minus 1.5, and we went across to the 0.09. Okay, so that gives us the minus 1.59 probability of a 0,0559, which, if we look at it, would have been that answer. Yes, Bongani.
So a negative 1.59, can't I round it to 1.6?
See,
Because we also have negative 1.6 on the table.
so would that then have given you probably that answer? So let's just, no, luckily not. So you can, let's just, for the assignment and for the exam, you need to round it off to 2 decimals, because the table allows you to go for 2 decimals. You could have looked at the 1 comma or the minus 1.6, because it's a easier one to find. You won't get an exact number, but you could be very close to it in any case. So for this, I would always round off a Z to 2 decimals and not just to 1 decimal. Just to make 100% sure. Okay, because there's a slight difference in the answer. They won't, and let's just be they won't give you that answer as an option and that as an option. So it won't be that those two will be your options. So if it's very close to it, you could have gone that route as well. But rather always round off to 2 decimals as they give in the table. Okay. Okay, so we'll continue on Saturday with this, but basically every time what we are doing is we always give you the Z, or we need to work out the Z. With the Z, we go to the Z table, and then I like to draw this or the normal distribution graph, just to give myself nearly an insight on what I'm looking for, and because this also nearly makes it a bit simpler for you to, if you get a weird answer or option, that you can nearly eliminate it. So let's just do one more, and then we can wrap it up for the evening. So here we need to work out the Z. So we need to work out the Z, but let's just look at what they give us. X is normally distributed. We've got the mean. We'll fill that in now. What is the probability that X is greater than? So so we will need to work out when it is greater than. So let's look at it. Greater than 145 minus the mean is 100 divided by 20. So what is it when it's greater? What is that? 45 over 20. I think that is 2 point something. So let's just make 100% sure what it is. 45 divided by 20 is 2.25. Okay, so we need to work out when Z is bigger than 2.25. Okay, so Z bigger than 2.25. Okay, so it is that area that we need to work out. Okay, so that is again, that is 0.5. That whole area is 0.5. I know that the area I'm looking for is smaller than 0.5. Smaller than 0.5, so that can't be an option. That can't be an option. That can't be an option. So we're actually, for this one, only sitting with 2. Okay, so the first one, how we can work it out is to say, well, remembering from that first question, when it is symmetrical, so if it is positive 2.25 on the one side, that is exactly the same size or probability as on the other side where it's negative 2.25. Okay, so that can be the one that we can look at. So then if we look at it that way, we can go to negative 2.25, 2.2, 2.25, and we'll see that the answer is 0.0122. So 0.0122. So that is if we look at the negative table, we can get that. But what we can also do is say, okay, well, I need to get that small area. I know from the positive table, I'm actually getting the other area. So from a positive table, I am getting this area. So if I then say 1 minus that area, that is this bigger yellow area. So let's just, if I say 1 minus that, I will get this purple area. Okay, so I will get that purple area when I say 1 minus the yellow. So let's look at what 2.25 would have been. 2.25 is there. Okay, so if I then said 1 minus 0.9878, I would have gotten, I hope, the same answer. So 1 minus 0.9878. I would have also gotten the 0.0122. Okay, so again, nearly find the one that's easier for you to do. I like this one where you swap it around, but again, it nearly, you will get both tables or you have access to both tables in the exam. So that's not gonna stop you in any way that you want to or can use it. So you've got access to both tables, and it's nearly which one will be easiest for you to work with. But definitely you can use both methods. Okay. So let's stop here for tonight. We'll continue on Saturday morning. So we'll just basically continue from where we stopped this evening. I'll put this on the group chat in a few minutes as well. I'll download it and add it to YouTube and just put it on the group chat if you want to go through it again before Saturday morning. But then Saturday we'll just continue with this. Any questions?